Space is big, really big. It's filled with billions and billions of stars. But stars aren't lonely. They like to hang out in big groups called galaxies. Our sun, the star that warms our planet, lives in a galaxy called the Milky Way. If you could see the Milky Way from far away, it would look like a giant, flat disk with spiral arms. There are many kinds of galaxies in the universe. Some are spirals like ours, others are shaped like balls or even have no particular shape at all. Just like stars gather in galaxies, galaxies themselves are not randomly scattered throughout space. They cluster together in groups, kind of like cities where galaxies live and interact. These groups are called, you guessed it, galaxy clusters. These clusters are held together by gravity, the same force that makes your feet stick to the ground. Gravity makes galaxies attract each other, pulling them closer and closer until they form a cluster. Some galaxy clusters are small, with just a few dozen members. Others are huge, containing thousands of galaxies. Think about a bunch of cities close to each other, forming a giant megacity. That's what a supercluster of galaxies is like. Superclusters are mind-bogglingly large collections of galaxy clusters, all bound together by gravity. These are some of the largest structures we know of in the entire universe. They are so big that it's hard to even imagine their size. It's like trying to picture all the grains of sand on all the beaches on Earth. We live in a supercluster too, but what exactly is a supercluster? It's a massive group of smaller galaxy clusters or galaxy groups, among the largest known structures of the cosmos. It's called Laniakea, a Hawaiian word meaning immeasurable heaven. This name is fitting, as Laniakea is truly vast and awe-inspiring. Our Milky Way galaxy, along with hundreds of thousands of other nearby galaxies, belongs to this giant cosmic structure. These galaxies are bound together by gravity, forming a colossal network of stars, planets, and other celestial bodies. Imagine Laniakea as a giant cosmic web. This web is made up of filaments of galaxies and dark matter, creating a complex and interconnected structure that spans across the universe. Galaxy clusters are like bright knots in this web, and our Milky Way is just one tiny point of light within one of those knots. Each knot represents a dense region of galaxies, all gravitationally bound to each other. Laniakea is about 500 million light-years across, making it one of the largest structures in the known universe. To put that into perspective, a light-year is the distance light travels in 1 year, which is about 5.88 trillion miles, which means it would take light, the fastest thing in the universe, 500 million years to travel from one end to the other. This incredible distance highlights the sheer scale of our cosmic neighborhood and the vastness of the universe we inhabit. Understanding our place within Laniakea helps us appreciate the grandeur of the cosmos and the intricate connections that bind us to the universe. It reminds us that we are part of something much larger than ourselves, a vast and wondrous cosmic tapestry. Section 5. Meet the giants Hercules, Corona Borealis, and others. Laniakea is huge, but it's not the biggest supercluster we know of. One of the largest is the Hercules Corona Borealis Great Wall. This supercluster is so big that it challenges our understanding of the early universe. How could something so enormous have formed so early on? Then there's the Hyperion Proto-Supercluster. It's so far away that we see it as it was billions of years ago, when the universe was still young. Studying these ancient giants helps us learn how the universe has evolved over time. Section 6. The Invisible Hand, Dark Matter and Superstructures. Gravity holds superclusters together, but there's a mystery. The gravity from the stuff we can see, stars, gas, and dust, isn't enough. There must be something else out there, something invisible, providing the extra gravity. We call this mysterious stuff dark matter. We can't see dark matter directly, but we know it's there because of its gravitational effects on the things we can see. It's like seeing a curtain move even though there's no wind. You know something invisible must be pushing it. Section 7. Imagining the immense from grains of sand to superclusters. It's hard to grasp the size of superclusters. These colossal structures are the largest known in the universe, spanning hundreds of millions of light-years. They contain thousands of galaxies, each with billions of stars, planets, and other celestial objects. They're so big that our brains have trouble wrapping around them. The sheer scale is beyond our everyday experience, making it difficult to visualize or comprehend. So, let's try an analogy. Analogies can help bridge the gap between the unimaginable and the familiar. giving us a way to relate to these vast cosmic structures. Imagine a grain of sand. This tiny particle is something we can easily hold and examine, a minuscule fragment of the world around us. Now imagine a whole beach full of sand. Each grain represents a star, and the beach represents a galaxy. The number of stars in a single galaxy is staggering, often reaching into the hundreds of billions. That's like comparing a single star to our Milky Way galaxy. The Milky Way itself is just one of billions of galaxies in the universe, each with its own vast collection of stars. Now imagine billions of beaches, each with billions of grains of sand. This is akin to a galaxy cluster, a massive assembly of galaxies bound together by gravity. That's like a galaxy cluster. These clusters are some of the largest structures in the universe, containing thousands of galaxies and stretching across vast distances. Finally, picture countless beaches stretching as far as you can see and beyond. That gives you a sense of the scale of a supercluster. Superclusters are the largest known structures in the cosmos, composed of multiple galaxy clusters. They span hundreds of millions of light-years and contain an unimaginable number of galaxies. This analogy helps us appreciate the immense scale of the universe, from the tiniest grains of sand to the vast superclusters that stretch across the cosmos. Section 8: Superclusters and the Expanding Universe. Remember how we said space is big? Well, it's getting bigger. The universe is not static, it's dynamic and ever-changing. This expansion was first observed by Edwin Hubble in the 1920s, who noticed that galaxies are moving away from us in all directions. This discovery was groundbreaking, and led to the formulation of Hubble's law, which states that the farther away a galaxy is, the faster it appears to be moving away. This was a pivotal moment in our understanding of the cosmos. The universe is expanding like a balloon being inflated. Imagine a balloon with dots on its surface. As you blow air into the balloon, the dots move away from each other. This is a simple analogy to help visualize the concept of cosmic expansion. The space between galaxies is stretching, causing them to drift apart over time. This expansion is driven by a mysterious force known as dark energy, which makes up about 68% of the universe. Dark energy is still one of the biggest mysteries in cosmology. As the universe expands, galaxies are moving away from each other. This movement is not due to the galaxies themselves traveling through space, but rather the space between them expanding. It's like raisins in a rising loaf of bread. The raisins move apart as the dough rises, not because they are moving on their own, but because the dough is expanding. This expansion affects everything on a cosmic scale, from the smallest galaxies to the largest superclusters. But gravity from superclusters is so strong that it can counteract this expansion, at least within the supercluster itself. Superclusters are the largest structures in the universe, consisting of thousands of galaxies bound together by gravity. These immense gravitational forces can hold galaxies together, even as the universe expands around them. This creates a delicate balance between the expansive force of dark energy and the attractive force of gravity. It's like dots drawn on a balloon. As the balloon inflates, the dots move apart, but those that are close together might stay clustered. This analogy helps us understand why galaxies within a supercluster remain gravitationally bound, even as the universe expands. The gravitational pull within a supercluster is strong enough to resist the stretching of space, keeping the galaxies in close proximity. But dots that are close together might stay clustered. This clustering effect is crucial for the formation and evolution of large-scale structures in the universe. It explains why we see vast networks of galaxies and superclusters, rather than a uniform distribution of galaxies throughout space. Understanding how superclusters form and evolve helps us learn more about the history of the universe and the forces at play within it. By studying these colossal structures, scientists can gain insights into the nature of dark matter and dark energy, the two most enigmatic components of our universe. This research not only deepens our knowledge of the cosmos, but also brings us closer to answering fundamental questions about the origin and fate of the universe. Section 9. Unraveling the Cosmic Web, the Future of Supercluster Studies. Superclusters are still full of mysteries. How did they form in the early universe? What will happen to them as the universe continues to expand? Astronomers are constantly observing superclusters with powerful telescopes, trying to unlock their secrets. By studying these cosmic giants, we're piecing together the story of our universe, from its earliest moments to its eventual fate. The more we learn about superclusters, the more we understand our own place in the grand scheme of things.